Hi, this is Thomas from 169A, and I'll be doing a robot explanation. So this is my state/US Open robot, and I'll start on the drivetrain. So I ran 600 RPM on 2.75 wheels, using 77 watts, with 4 11 watts on the bottom, one 11 watt one 148 tooth gear up, and then in the back we have a 5.5 watt motor. So the reason we did this in the beginning is for states we made it really easy for here to have a PTO, but the PTO didn't really work out and it got stuck a lot of times, so we decided just to take it off because the PTO was for our vertical hang, but the hang didn't really work out during states, so we decided to switch it to a horizontal bar hang during US Open. Moving on to the intake, we ran a one motor intake on 600 RPM because we used 77 watts on the drivetrain, so we had one motor left. And we just did a hot swap with the kicker, as we found the kicker wasn't really useful during normal matches, and it was just used for skills. So what we did was we just had the kicker and we made it perfectly fit the hang, and we'd have standoffs at the bottom of the hang to be able to screw on the screws we already have on the kicker really quickly. And we could just hot swap the motor off really quickly and just have the kicker for the skills runs and the intake for the matches. And as for the intake, we actually had an angled intake, so these two C channels they're connected and they're positioned at an angle, so when we lift the intake up, our polycarbonate piece at the bottom could be pushed outwards, and this just acts like a passive puncher mechanism. So when the tri-ball is in here, when we go and score, the intake will be lifted up, and the polycarbonate would act like a support to push the tri-ball out, and it just made outtaking a much easier process. Moving on from the intake, we have our wings, which are pretty standard. We ran 4 wings with back wings using single acting, and these polycarbonate pieces just made getting the tri-ball out of the corner really smooth, as they just lift the tri-ball up. And we used to have wedge polycarb, but they're on this robot right now, so we wedge them and we secure them with zip ties. It just makes the wings lighter. And as for the hang, we originally had a vertical C-tier hang that would be winched from here, but we realized it was too slow, and the PTO sometimes did not work really well. So for US Open, we switched to a horizontal bar hang, and we use these one by one aluminum channels because we were pretty stacked on polycarb. I've got pieces here, and they were all doubled, so we just did not want to have the polycarb, as it would just get us way too close to our limit. But these angled pieces worked out pretty well. They got C tier most of the times, so that was good. We ran it on 4 75mm pistons that are attached to one tank, so we would run all the wings on this tank and then the hang on this tank, just to have maximum air when we go and hang. Lastly, for the sleds, I used the sandwich method to have a piece of aluminum inside between 2 pieces of polycarbonate, and I bent them inwards during US Open because all the fields were steel fields and the polycarbonate would just get stuck in those fields, which is why I did that. But we actually found out it breaks really easily, so on this one, the bent part would just break really easily because just combat and like pushing with other robots just breaks them. So it didn't really work out really well, but overall the bot was okay. It's unfortunate we couldn't go to Worlds, but I thought that it was still a really good bot. And moving on to the Dcore bot, we actually built this because all the teams in our state wanted to scrim and have practice against the Dcore bot. So I just made a similar version to 1095R's robot and allowed them to have a bot to play against that can D-score. So on the drivetrain, it's pretty similar to their drivetrain. I ran a 77 watt drivetrain with 2 5.5s and 6 11 watts. And she made the whole drivetrain less wide. So instead of thick 36 tooth gears, I used thin ones just to make the wheels 5-hole wide instead of 6-hole. Otherwise, the gearing is pretty standard. We have the 36 tooth gear in here that would gear to the 12th, and that would gear with the entire 36 tooth gear to make a 600 RPM on 2.75 wheels with the 2-inch Black's Flex wheels in the middle. We actually have our 2 tanks back here because we found the intake actually made a lot of the stuff really heavy because we ran a 2 5.5 watt motor, 400 RPM intake. The reason we did this instead of a 1 motor 600 RPM is because we didn't want a motor to stick out, and since when we had the intake down, the larger motor would just stick out on top, and it made D-scoring less smooth because this would make more clearance. And also the position of these 2 motors just made match loading from the top a lot easier, as the position of these 2 just was perfect for the tip of the tri-ball to just fit into here, and like wherever you throw it, it just goes like directly like in this position, and it just made match loading a lot easier. And another part of the intake was we have this rubber band mechanism here, and it kind of acts like a trapdoor. So when we place from the top, the tri-ball would go in, and it would push down on the rubber band, and the rubber band would give away. But when we push up from the intake, or like the robot, like the tri-ball tries to get out, the rubber band would just stop it from coming out. And it almost never came out unless like there was another tri-ball that would be intaken here in double possession. That's like the only possible time we ran into it. But overall, the intake worked pretty nicely. And with the 2 pistons here, we were able to release the intake downwards and to be able to D-score. And because we didn't have odometry, unlike this robot, we had to, for the left side auto, we have to rely on this distance sensor. So we would put the intake down and drive under the bar, and it would just sense the bar, the horizontal bar, and touch it for the autonomous swim point. Moving on to the wings, we had 2 front wings that had wedge polycarb, and then the 2 back wings that allowed for hang and autonomous D-scoring the tri-ball from the match load zone. So how this one worked is this was low enough for the piston to go down and lift the robot up, and we found that the arm was a bit too short in the D-scoring, so I added this additional like extender. So how it works is when we flip the intake out, this would extend outwards, but when we flip it in, the force would just make it like go back in. And since it can't stand still like this, it would just fall back down, and we would still be in the height to like D-score. Same one. We just did it on one side because it was not needed for the additional side. So because there was sometimes like it wouldn't come down really well, as like the wing just sustained a lot of force and then it started to bend. So it didn't come down really well, so we just kept it on one one of the wings. For the sleds, we did some improvements on this robot. So we made them tangent to the wheel, so this sled was able to tangent directly to the path of the wheel. And we made the polycarbonate really small, so like they would never break. Unlike the ones on this robot, they would like be really large, and we really did not need this much of a piece. And it just added extra weight, and having a smaller like sled, it would also, the polycarbonate will less likely to break, because just having it larger makes it more likely to break. And just the small sleds worked really well. They went over the bar really quickly, and overall it was a pretty good sled. I'll recommend that. And I guess lastly, for sensors, we used 2 inertials in this position and this position. The 2 just balanced errors out, because the inertial sensor can drift, and the 2 just made we just calculated them and then averaged them out to make the overall programming much more accurate. And overall, yeah, it's unfortunate we couldn't go to Worlds, but I wish everyone who can go to Worlds good luck at Worlds, and thanks.